Okay, so just a couple things I want you to do here. First of all, I want you to convert this into a fraction. Convert this into a fraction. And then after you do that, I want to see if you can tell me if this is repeating or terminating just by looking at it. And then I want you to do long division to figure out what the decimal value actually is. And then same thing over here, I want you to tell me without dividing if it's repeating or terminal, and then I want you to divide and figure out where it is. So pause the computer for a second here, see if you can do these 4 problems. If not, you might need to go back and watch some of the other videos again, just to make sure you have this in your mind. So go ahead and pause, and then we'll come back. Okay, so let's look at these first two. Terminating are nice. You just put it over the place values. So this is what, tenths, hundredths, thousandths. And then you just have to simplify. So you could divide by 5. I noticed that I think of like $1.25 here. So that would go in there, 5 times, and 25 would go into that, part by 4 maybe? And divide by 5, and it looks like 1/8. And some of us might have that memorized because remember, a fourth is 25%. Sorry, this is bouncing around a lot. And then 1/8 would be half of that, 12.5%, and then decimal form. So some people might have that memorized, but again, you should be able to figure it out. Repeating decimals are also rational numbers. Both of these are rational numbers because you can put them into ratio form. So if it has that repeating line over it, that means you can make it into a fraction. And from previous videos, there are 2 ways to do that. One is to remember that 99s and 9s give you repeating. So remember, like, 3 9s would give you 0.3 repeating, 1 9th would give you 0.1 repeating, and then if you have 2 repeatings, you'd be in the next place value over, so that would be 99. And so knowing that patterns at 9, 99s, 999s, 9,999 all give you those nice repeating. So, but then again, I know my divisibility rules. If I add this up, it's 18. Add that up, that's 3. So I know both of these are divisible by 3. So it looks like that is what? 4, is that 4 over 33? Okay. And the other way of doing that, so notice this can be converted, this is a ratio, so that's why repeating decimals are rational. The other thing I could do here is do that n trick. So I could let n be 0.12 repeating. If I multiply by 10, that's just going to move the decimal once, so then it's going to be 1.21212121, repeating. That doesn't help me subtract because, again, if I put the line over now, the 2-1, that's still going to be repeating stuff there. So that doesn't really help me too much. I could try multiplying by 100, and that's going to move the decimal. And then it's going to go 121212 after that, so that's nice. So then I'm like, okay, this one's not going to help me, but these two are. So I'm going to subtract n. And remember, your goal on these is to line up the repeating decimal. So those line up. I get 99n equals 12. And then to get rid of multiplying, you divide. And notice it gets me to that 99 just like here if you have this memorized. And then what? Divide by 3, and I still get 4 over 33. And again, if you want to double check with the calculator to make sure that that actually worked, you can do that. So make sure you can put repeating decimals and terminating decimals back into their fraction form. All right, so let's look at both of these. So if you want to write this as a fraction, you could, and I think in class we talked about, can I just simplify this? You could. 51, it adds up to 6, this adds up to 12. So I do know they're both divisible by 3. I could do that. The other thing I could do is do prime factorization and kind of see what's going on there. So this is what, 3 and what, 17, and then 48 is what, 6 and 8, which is 2, 3, and then 2 times 2 times 2. And so then I could look at what happens with my factors. So I have 3 times 17 all over, what, 4 2s and a 3. And notice those 3's cancel. So even though there's a 3 in it, it's going to divide out. And so if I look at all these 2's here, I know that this is going to be terminating because 2's and 5's go into base 10 things nicely. And so because that 3 cancels out, I know this is going to be terminating. And so to divide it, again, the first number always goes into your little house thing. And you're going to put a decimal here because you know you're going to not go in there perfectly. 48 goes into 51 once, and you put it above the place value. And you get 3. Bring down your 0. And again, your decimal, we didn't move anything around. We didn't compensate, so we're good. 48 goes into 30 0 times. So you got to put a 0. And then you're going to bring down another 0. And let's see, 48 times 6, that's probably too much. 48 times 6 is 48. So what is that? 24, 25, 26, 27, 28? Oh, that's not. Okay. Let me double check. I think that's okay. 6 times 8 is 48. 4, 24. I think I'm good. All right, so I do get that. Now again, here adding on, I can just see it's 12. But if you need to ungroup and get a 10, and then ungroup and get a 9 and get a 10, you can do that too. So then I'm going to bring down another 0 here. So 3 looks too big, so I'm going to try 2. 16, what is that, 896? So that's a 2. Again, you might want to add on 4 would get me up to 100, so I know it's 24. Again, you could always ungroup, make that a 10, and then 10 minus that, and then ungroup and make that an 11. You can get it that way. And then now I'm going to bring down a 0. And I'm expecting to get a 5 at some point here because 2 goes into 10 5 times. So let's see, what do I get? A 40. So there's my 240. All right, so 5 and I use 240. And when my remainder is finally 0, then I know I'm done. And so it's a terminating decimal there. And there's my answer. It makes sense that it's more than 1 because 51 over 48, 48 goes in there once. So it is going to be 1 point something. All right, let's look at this 5/7. So I have 5 divided by 7. And again, if I write it in fraction form, that would be 5/7. Here they have nothing in common, and they're actually both prime. So I can look at 7, and it's not all 2's and 5's. Obviously, it's just a 7. So I know this is going to be a repeating decimal. And so I'm going to go ahead and divide this, expecting, I know there's going to be a repeating decimal. First number always goes in your little house thing. 7 goes here. And so I'm going to put my 0 because I know I'm going to get a decimal here. All right, so 7 doesn't go into 5, so you can put 0 if you want, or just leave it. 7 goes in there, what? 7 is 49. Get a 1, bring down your 0 as a 10. 7 goes into 10, what? Once. And I get 3. So notice here I got a remainder of 1, here I got a remainder of 3. My only possibilities here are 0 through 6. Right? 0 would, if I get a remainder of 0, obviously it's terminating, but I could get a remainder of 1, 2, 3, 4, 5, or 6 before it would repeat. So I'm going to bring down my 0. 7 goes in there, what? 4 is 28. This time I get a remainder of 2, so I'm getting all new remainders, which is good because if I was repeating, then I know I'm ready to stop and look. 7 goes in there twice, so I get 14. Which is 6. And so then I'm going to bring down a 0. 67 times what? 7 times 7 is 49, sometimes 8 is 56. I get a remainder of 4. Haven't had that yet. 7, so again, bring down a 0. I'm not sure what you guys can see. Can you still see that on the screen? Let me look. Barely. Okay. So 7 times what? 5 is 35. And then I get a 5. Yeah, I'm just going to kind of put that 5 over here. So I'm just going to put the 5 and bring a 0 down. So 7 goes in there, which is 49. And notice I've seen a 7 before. So notice I'm getting a remainder of 1 again. And I had a remainder of 1 here. Again, I could keep bringing down zeros and that become a 10. And 7 goes into 10 once with a remainder of 3. And again, notice you've had 3 before. You could bring down a 0 again. 30. And then again, notice you would get that remainder. So As soon as I got that repeat remainder, I don't have to keep dividing. I knew at this point that that was a repeat remainder. And so you can keep dividing to see it, but you don't need it. All of this is repeating. So go 7, 1, 4, 2, 8, 5, then it's going to go 7, 1. So to write my answer, 7, 1, 4, 2, 8, 5. And again, it all gets a line over it because it's all repeating. If only part of it repeated, obviously we'd only put the line over that part. Now again, notice I had to divide quite a few places. 1, 2, 3, 4, 5, 6 place values. And the issue is with 7, you could get a remainder of 1, you could get a remainder of 2, you could get a remainder of 3, remainder of 4, remainder of 5, remainder of 6. You can't get a remainder of 7 because that means you should have picked a bigger number up here. And you can't get a remainder of 0 because then this would have had to been a terminating decimal. So, you know, there are 6, 1, 2, 3, 4, 5, 6 times I had to divide, and this time I actually had to do all 6 of them to figure out what my repeating decimal was. And that's kind of the worst case scenario. Sometimes you find it sooner, which is nice. All right, let's see where we're at on time. All right, I'm going to end there. So with this video, actually, yeah, I'm going to end here, and I'll do another geometry one in a separate video. Keep working hard.